everybody, this is Ananya and today's topic of discussion is on broadcasting. So instead of understanding as to what broadcasting is directly through any sort of definition, let's look at a few examples first. Let's say you had to add two Numpy arrays and there you go, here are your two arrays. Consider that both of them are of the exact same length. Now, do you think there should be any issue with adding them? No, right? It's absolutely fine. Let's go ahead and execute that. Well, there you go. No issue. Let's have a small pictorial depiction of how it works out. You have the two arrays. What basically happens here is the index position of one array gets added up with the same index position of another array. Pretty simple. 1 plus 8, you get a 9. 2 plus 9, you get an 11. Pretty simple, that's no issue. But what if the length of one array was not the same as the other? How do you think you'd go about that? Well, of course, there would be an issue, right? Because the last addition would be 7 plus 14. But what if you had an extra element 15 in the second array? Poor number 15 would be left out all alone with nothing to be added up to, right? So this is where the term broadcasting actually comes into play. Let's have a look with this pictorial explanation. Let's say you have a radio station where a single person is broadcasting, let's say some sound or music, to many people in a certain locality or area. This exact picture, place it in the terms of your Numpy arrays. You have one single array, or let's say one person, broadcasting to many people. One to many, or let's say small to large, right? Now have a look at this. Can you see the same pictorial depiction in the case of Numpy arrays too? You have a single number 8 and you are broadcasting it to each index of the longer array, small to large. Now let's see the same thing via a code. We'll have a certain set of rules coming also, which you will understand through examples. You don't have to actually look at them. Let me show you all how an error might also occur in the case if there was an extra element. Let's say it was 15. And now if I run this, there you go, you're going to have a value error saying operands could not be broadcast together because the shapes are different. Let us look at an actual broadcasting example that we just saw pictorially. Here's your two arrays, and for the time being, let's take a single element. Alright, and there you go. Let me just remove this. Let me enlarge in that also. There you go. You have your first array, right? And you have another array containing only one element. And for now, let me remove all the others from here. Let's keep it as 1, 2, 3, 4 only. Or let me give a 5, 6, 7, and 8. Okay. Do you think there would be any problem with adding this up? Well, we just saw there won't be any issue. Why? Because of broadcasting. And here is your original array, your second array, and the addition of both of them. Right? Now, what if it wasn't a single element array? What if there were multiple numbers inside it? What would you do then? Well, it's pretty similar. Have a look at this array, your array A, and this being array B. This is basically a multi-dimensional array having 4 columns and 3 rows. And the second array that is to be added up with the first has 4 columns. Is the addition possible? Let's see how this actually works out. So, you have 1, 2, 3, 4 as your first row. Also, 2, 4, 6, 8 being your first row. Let's add that up. That shouldn't be an issue. 4 columns and 1 row. And your first row of your resultant array will be 3, 6, 9, 12 as you all can see on the screen. But what next? You have 5, 6, 7, 8 also and a third row. What basically happens in broadcasting is you can stretch the array, right? Let's go ahead and copy it. And imagine this as another second array being created like virtually for the second row. Now if you add this up, you get the second resultant row, that is 7, 10, 13 and 16. Do the same exact thing for your third row. 9, 10, 11, 12 plus 2, 4, 6, 8. And let me place another one here. Pretty easy for imagining, right? You see how each of them get stretched. Each of them meaning only the second array that has to be added. And most importantly, the array that will be stretched is your smaller array and not the bigger one. Okay, now let's have a small note where you will get to see as to which rules need to be followed for broadcasting to be applicable. You have all the input arrays of the same size. Okay, I hope you all can see this. Okay, I'll place it here because you all can already see what's going on pictorially. All the input arrays have the same shape, right? We just saw that. It shouldn't be any issue, right? Normal addition when the lengths are the same. Second point, arrays have the same number of dimensions and the length of each dimension is either common or the length is 1. Remember the example that we just saw. The first one wherein the length was the same. Okay, there you go. Let me run it again. The length was the same or the length is 1. And if there is a change in the dimensions, what you can do is append the shape with 1. That basically means you will be stretching it as we saw here. Let's go and see the example of the last one. And there you go. This is the exact same example that we just took. Let me run this and show it to you all. And I'm pretty sure you all will understand as to what happened. You have array A and array B which resulted into this. Now what if I was to change the dimension of the second array? Instead of 1 row, I want to make it 2 rows and try and add it. Well, this time, if you guessed it correctly, we will be having an error. It's not going to give us the output and there you go. Data type is not understood. And that's where everything about broadcasting gets covered. Where and how you can use it to add arrays of different lengths. Simple, same length arrays, no issue. But what if there was a different length arrays? What if there were different lengths? Broadcasting is your solution. Well, I hope you all understood broadcasting. Next time, we'll come up with a few more exercises like every time. Practice them and get better. Till then, bye-bye.